Ok.
Hello.
No. Yeah, analysis. Why? Still a niche no on niche kind of speaker.
Oh, can you hear my voice?
Yeah.
Okay.
Yes.
What? Oh, okay. It's a
Hello.
Hello, everyone. Can you hear my voice?
Yeah.
Okay. Thank you
Yeah.
very much for your joining at this webinar meeting. So today, we would like to have the very dedicated sales meeting about the full vacuum FTIR. The reason why we choose this issue, this item topic, was of course when we promote the FTIR in the world, there are many competitors like Thermo, Bruker, Agilent, Shimazu. But when we focus on a dedicated application like a full vacuum application, we can fight less competitive. I mean, main competitor should be the only Bruker. So today we would like to introduce several product information, system configuration, and also application so that you guys can promote full vacuum FTIR against Bruker in your territory. So today, our Masato will have presentation about this full vacuum FTIR. It will be maybe 25 minutes presentation. So later after that, we like to have kind of like a question and answer time. But today we have many participants, like over 40. So it's not easy to catch up everybody's opinion or question. So later after, we would like to share this presentation material through Massimo. And then we are very welcome to receive any question and comment about this webinar. Okay? So anyway, thank you very much. Shall we start it? Ready?
Hello?
can you see this slide? Okay.
Yes.
Okay. Thank you for your joining this sales webinar. I'm Masato. Today we'll talk about full vacuum FTIR. We'll hear about full vacuum. It feels like a very special system for only limited customers. However, in fact, it's worth owning it for all customers. We think it's good to promote this full vacuum IR in your business because it has some advantage like better data. First, I am telling you, why do we need to recommend full vacuum FTIR? Then we would like to introduce applications, competitive models, and customer-made case studies. In the end, we like to have quick question time. If you have any questions, we will be happy to put them together at the end of this session. Okay. So why do we need to recommend full vacuum FTIR? weak peaks becomes visible at mid-IR regions. It is necessary to remove the atmosphere at the measurement in far regions. N2 purge is not enough. Most computers do not have full vacuum FTIR. Let's look at each of these points in detail. It makes weak peaks visible at mid-IR regions. This diagram shows the spectrum of polypropylene measured in air and vacuum conditions. The green line in air and the red line is in vacuum conditions. In the green line spectrum, there is a micro peaks hidden by water vapor absorption. The micro peaks on red line may be additives in polypropylene. By evacuating the entire optical path, we can obtain a spectrum of sample clearly and purity. It is necessary to remove the atmosphere at the measurement in far region. This figure indicates comparisons about the single beam in the fine infrared regions and the nitrogen purges and the vacuum conditions. Since the light is not absorption by atmosphere, the energy increase in the area covered by absorption. In the far IR regions, measurement under vacuum conditions can extend it by dynamic range. As shown in the figure, the nitrogen purge does not completely replace the sample compartment with nitrogens. Many customers think of using argon or neon gases instead of nitrogens, but these gases are prohibited to be used. If the nitrogen purge is not satisfactory, a full vacuum model should be used. A certain number of users are not satisfied with the N2 purging after starting to use it. However, it is not possible to upgrade from a standard model to full vacuum models. For customers who evaluating peaks that overlap with water vapor or carbon dioxide absorption, we recommend proposing a vacuum model from the beginning. Most competitors do not have a full vacuum FTIR. There are many competitors in FTIR, so Shima's Parkin thermal bulkers. However, only JASC or Bulka, the only manufacturer in vacuum FTIR. Even in the case of tenders, you can bid on favorable terms and prices. Let's look at some mid-IR applications. High sensitivity refraction measurements. RAS measurements are easy to proposal for full vacuum models and their effects are easy to understand. The intensity of the peaks due to the thin film on metal and the peaks due to the atmosphere are almost the same. If the peaks are hidden by the absorption of water vapor, quantitative evaluation is not possible if the peaks can be seen. Therefore, it is better to measure under vacuum conditions, as the spectra do not contain any information other than of the sample, making evaluation easier. So the basic configuration RAS measurement looks like this. In particular, we recommend the FTIR 6XFV, which uses a semiconductor laser and is highly competitive. The FTIR 8X series is recommended to be proposed when step scan or high resolution or for IR measurement specific applications are required. When using RAS units, if the sample area is less than 20 times 10 millimeter, an MCT detector is required. What is the automatic gate valve and window changer unit? So EXPT6XWGV automated gate valve and window changer unit. It is a unique option of JASCO. It has 3 window spreads for each wave number range from FIR, mid-IR, and NIR. And full vacuum FTIR can be measured without a window plate. It eliminates the window plate absorption, allowing the true performance of the FTIR to be demonstrated and a wide range measurement. Determination of trace amount of moistures. An advantage on gas sample measurement is that atmosphere is not measured. When used to measure trace amount of moisture and carbon dioxide in gases, as shown in the spectrum, it is possible to quantify to the several hundred ppb level. So gas measurement configurations. So the 12-meter gas cell required a window plate to be selected at the time of purchase. The material of window plate should be changed depending on which peaks of the gas be quantified is to be used and whether water vapor is removed from the measurement gas. MCT or bandpass filter may also be required depending on required quantitation accuracy and the peaks to be quantified. A heated jacket is necessary to prevent error due to the gas absorption into the cell or temperature changes. Gas temperature and pressure can also be monitored to correct the quantitation curve. To configuration a system for the determination of trace compartment gases, it is important to know which trace components in which matrix gas are measured and with what accuracy. So for a consultation on system configurations, please contact us with the above information. So before looking at the next FIRE application example, we introduce the broadband system. A broadband system can measure the wide wave number ranges without switching optical elements. The use of semiconductor laser makes the system high competitive with low maintenance requirements. The beam splitter is made of silicon materials, so expensive optical elements will not be damaged even if customer puts the atmosphere inside the interferometer by mistake. Both windowless and windowless measurement are possible, allowing measurements in the mid-IR region without a vacuum. Broadband system configurations. So by using a diode laser, silicon beam splitter, and automated gate valve and window changer unit, broadband system with low maintenance requirements can be archived. If customer only needs to take a wide range of spectra at the time with a resolution of 4, you can use BBTG S6 alone. If customer wants to measure the high resolution spectra or far in IR region in detail, we recommended adding a polyethylene window TGS. As an accessory, we recommended adding an ATR with PKS-DNF, which can be used for both solid and liquid samples regardless of the measurement wave number. liquid measurements using ATR in NIR and FIR regions. The advantage on liquid sample measurement is that only the OH band of the solvent can be OH band of solvent can be evaluated. Using full vacuum FTIR allows for the first time to evaluate the effect of water molecular vibrations and different conditions such as the temperature, pressure, and ion concentrations. It is possible to evaluate minute change in OH vibration not only in the mid-IR regions but also FIR and NIR. The spectrum shown below in an organic carbonate spectrum. It can be seen in the FIR region, differences in the crystal structure and vibration of heavy atoms can be observed. The most common use for such measurements of inorganic materials is the analysis of pigments in wall paintings, such as those of cultural heritage. The advantage of using FTIR in the analysis of cultural heritage is that it is possible to analyze inorganic minerals in the FIR and binder materials such as wax and resin in the mid-IR all at once. So in the FIR regions, peaks due to lattice vibration caused by the crystal structure can be seen in addition to molecular vibrations. Even with the same chemical structure, such as calcium carbon oxide 3, the shape of the peaks differs greatly if the crystal structure is different, as in the case of calcite and aragonite. So, unlike X-ray diffraction measurements, the crystal cultures cannot be calculated from the spectrum, but it can be identified the crystal structure by comparison with the spectrum of a standard sample. This means that simple screening of crystal structure is possible with FTIR. FIR measurement organic. Differences in crystal structure exist not only in organic materials but also in organic compounds. The data presented here compares two fishing lines. In the mid-IR regions alone, it is difficult to determine whether the differences is due to the crystal structure or the influence of the additives. But in the FIR regions, the peaks are clearly different, indicating that these have different crystal structures. Chemical manufacturers use X-ray diffraction methods less frequency, making them difficult to own. However, prescreening with daily use FTIR makes it possible to send only the required sample to the analytical service. Next, quantitative information. As you have just seen, the only competitor in vacuum IR is Vulcan. We'll now focus on Vulcan's vacuum models only. The only competing models are Vertex series 70V and 80V. As shown in the table, JASCO is better in terms of maximum resolution and convenience, and the size of equipment is compact. The signal-to-noise ratio is not shown in the specification comparison of vacuum models because it does not mean anything. Model using diode laser do not require high frequency maintenance. Both FTIR 6X and 8X models have little workload that the user has to perform, as the beam splitter, window plate, and detector can be replaced automatically, and the needed to touch the optical element can be eliminated. Broadcast IR focus on very niche points such as rapid scan and wide range measurement. We estimate the number of cells of 70V was just 5 units and almost 0 unit of 80Vs in Japanese domestic market in a year. Current reaction measurement of glue that require rapid scan are often not experiments that use vacuum models. So customers wishing want to measure up to 50,000 with a single instrument are limited to sunlight, laser, and very few solid material studies. JASC sold 10 full vacuum FTIRs to Japan last year. As we don't often have the full vacuum models as competitors in Japan, we would like to know if you have competed with them. Ulka sometimes tells customers that the higher vacuum FTIR is better its performance. This is mixed with sunlight. Atmosphere peaks and noise disappear from the spectrum at around 0.2 hectopascal. So there are few cases where higher vacuum is required. And the price of broadcast is expensive, and it makes most customers choose JASCO before sample measurement or performance evaluation. JASCO broadband system versus Bruker FM. So the most likely vacuum IR competitor to emerge is the Bruker FM Vertex 70V. The wavelength range and the maximum resolution are not much different, but the broadband system our broadband system requires less maintenance and is most cost effective. So automated broadband measurement system. When using multiple beam splitters, it is recommended to use an automatic beam splitter exchange unit. By combining the best beam splitter and detector for the measurement range, we obtain the best performing FTIR. The only competent model with an automatic beam splitter exchange unit is the Vertex 80V. For customers who want to measure up the UV range, we recommend to propose a set of the FTIR and the spectral photometer. If we want to measure up to visible regions, we recommend using the FTIR 6FV as the main unit. The FTIR 8X FV has to change custom-made aluminum mirror for visible range. It required a longer delivery time. We recommend to only propose 8X FV when high resolution is absolutely necessary. Also, we should be noted the rapid scan is detector-dependent features, which limits the usable wave number ranges. This automated broadband measurement system configurations. So the configuration can measure from visible to far. The FTIR 6X needs to be changed from diode laser to helium neon laser for visible range compatibility. This system can measure a wide band with high resolution using a better combination of detector and beam splitter. If customer need FTIR system that specialize in the FTIR region rather than the broadband system, propose a configuration like this. The FTIR ATX can use minor beam splitter, allowing you to configuration a highly efficient for IR measurement system. The following example of past customer orders. Cryostat holders. Cryostats are essentially for the evaluation of the physical properties of advanced materials such as semiconductors. This holder can install a helium temperature cryostat in the sample compartment. It is currently compatible with Oxford Optics DN and Optistat CF. For the cryostat, please contact us. Sample folder for RF81S. After using the measurement unit, we need to open the sample compartment once between background and sample measurements. This custom order is modified from RF81S and front panel. A customer can switch the sample by operating a lever from the outside. It is very useful that customer switches between the background and sample under vacuum. So wafer holder for vacuum FTIR. This unit is specialized wafer measurement. Customer can switch between the sample and background and measurement multiple points of the sample under vacuum. If measuring only a fixed sample as If measuring only a fixed sample as in this unit, we are possible to propose measurement accessories specifically designed for it. This is the end of the introduction to the custom order. So for this presentation, we use data from application data and the displayed posters presented by Tamura-san at SciEx 2023. Thank you for your attention. Sorry. Okay. Thank you for your attention. So, any questions?
No.
No. No. どうしましょう。
Could you detail the gate valve system? Because in the presentation, it seems there is no window in standard, and I think it's not clear for me. Thank you.
なるほど。Okay. So, this gate valve changer unit has three. Sorry. 先にこれレーザーポインターにしなきゃいけない。よいしょ。Okay. So this gate valve changer unit has three window plates. So for this. So KRS5 windows, calcium F2 windows, polyethylene windows. This position is not window plates. So one window position is have no window plates. Other three positions has each window plates materials.
Okay, and the window are included in standard, or we have to order it separately and is an option?
So these window materials included this changer unit.
Okay.
Yeah, Jean-Philippe, in the past, you have to select the windows during the configuration. So you have the gate valve with Windows KRS5 or with Polythene or with CFF2. Now you have one wheel that including the three windows always and the whole without windows is a different between the past.
Okay, that's why I was confusing. I was confused because I didn't know if it was included or not.
No, are included.
Okay.
I have, it's not a question. My question is just to try to point out what should be some needs of our colleague that is selling FTIR in Europe and in Middle East. We usually receiving requests for full vacuum FTIR, especially for measurement of semiconductor laser, for black body furnace experiments, or FTIR that is able to work in the far IR region by using a bolometer. I know that we can go up to 20 wave number. This happened when the mercury lamp has been discontinued. In the past, we work up to 10 wave number. I think that we have a couple of installation in Italy is working with bolometer, or at least one for sure, and the other one is thinking to add a bolometer in order to work up to 10. But in that case, we had the mercury lamp. So my question is, sometimes it's not difficult, but you need a lot of time to make a reply. Is it possible to have a standard configuration, 3 standard configuration, including all the optics in order to accommodate an external laser, an external furnace, maybe giving some indication about which kind of black body and furnace locally dealer have to purchase, and optics in order to use a bolometer from detector side. 3 standard configuration in order to have at least the feeling of what should be the price and in order to give an immediate reply to the customer. And then we can maybe expand the configuration because the request is not for a standard system, but at least customer could have an idea. And also we can propose quite immediately a solution to the customer. Is it possible? That's the question.
Thanks, Massimo, for your comment. So yeah, that's a good point. So we like to do some work to prepare some material or configuration plans information so that you guys provide customer easier and quick. So please let me talk in Japanese language with engineers here. What's the topic we are talking about? Please hold on. So Mashimo, we would like to prepare some kind of material for you guys to sales promotion more easier, especially about fire IR measurement using borometer and other detector. So what we'd like to do that. Thank you very much for your good advice. And yeah, go ahead.
Now, just to add, since you are, maybe also some additional explanation and configuration about PM ERAS
PM
experiments. It's not so often that we are receiving inquiry, but also having a sort of some more detailed explanation about PM ERAS, including some price ordering info that we already had in the past, that this is for sure, but having some more technical explanation, because price, we know about the price, that's not a big problem, but just to understand something better about what we can do, also comparing with maybe the main competitor that we could have, that this is Bruker. Bruker is offering a PM, it's called PM 50 or something like that, accessory attachment. That seems something standard for them. So this is the perception of the customer, that is purchasing something standard. For us, it's always something special, and not always is a good to propose something special instead of standard one. So having a brief, how can I say, presentation of PM ERAS, what we can do, what should be our key point versus Bruker and Thermo 2 also, if I remember correctly, just to have a picture of the system. That is always something in my mind exotic, difficult to understand. What should be our key point?
Okay. So this time, we focus on very basic full vacuum configuration and application. So we like to add such type of the different configuration and application. So it's good chance for us to keep talking and to expand possibility to sell our FTIR in European region continuously. Okay. So before answering some other question, I would like to say that this webinar was recorded. So later, after this webinar, I would like to edit it all and put it YouTube, so everybody watch it and with sales material. And also, this slide will be shared through the JBox or somewhere. And the very end of this slide, it's included some poster material which we used in a SciEx conference in US. That is very good, some kind of like a sales tool for you to use for customer to understand our full vacuum system. So anyway, later I'll follow up that kind of things. Okay. And we got some chat on a question, so we like to answer it. Massimo, we received a couple questions on a chat. So later we like to write down all question and we send it back to you with answer. If so, everybody can share that information.
Yes.
And then after that, if you have any question, please send the email to Mashimo and us, and we try to follow up everything after that. Okay, so once again, thank you very much for or attending this webinar. And later we like to prepare something for everybody to use this material and video content for further learning. And then we would like to keep having this type of webinar contents continuously for European colleagues. Maybe this year we like to not this year, but until the coming 10 months is we like to have 3 different contents on this webinar. Okay, anyway, thank you very much for joining.
Thank you.
So we would like to see you next time. Thank you very much.
Thank you.
Thank
Bye-bye.
you.
Thank
Thank
you
you.
so much.
Thank
very
you.
much.
Thank you.
Bye
Thank you.
bye.
Bye-bye.
Bye. Bye. でもいいよ、消しちゃって。
Mhm.
ああ、そうしようか。
Bye.
Thank you very much. Goodbye.
Bye bye.
Bye. Thank you.